So this time it's the same graph, y equals to 1 over x squared. We drew this last time. And if we integrate from 1 through infinity, that means we're trying to get the area from 1 until infinity. Now your immediate intuition would be that, oh, this goes to infinity, so the area must be infinity, right? But watch what this says. First of all, because it has an infinity, anytime you get an infinity or you're approaching a point where the function becomes infinity, you have to substitute it with a limit, right? So you have to take limit a going to infinity of integral from 1 through a of 1 over x squared dx. And then this integral is negative 1 over x, and you plug in a and 1. Still, you have to take a to infinity, which gives you negative 1 over a minus negative 1 over 1, limit a going to infinity. And now you see that 1 over infinity is what? What's 1 over infinity? 0. And negative of negative is positive 1, so you get 1. Now that's somewhat puzzling if you have never seen such a thing. So apparently the length of this base of this portion is infinity, but still the area is a finite number. So how do you understand that? Well, I guess there are several ways to understand it, but one way I would do it is by dividing this into, say, 1 to 2, 2 to 3, and then 3 to 4, and so on. And calculate the following integral in general. If you have an integer n, and you integrate until n plus 1 of this 1 over x squared dx, that's going to be negative 1 over x, n plus 1, and n, where when this goes in here, it's negative 1 over n plus 1. When n takes the place of x, then it's minus of negative 1 over n. Right? This plugged in, you're subtracting the 2, right? So after turning this into positive, this is what you get. So that formula can be used to calculate, for example, when n is 1, what's the integral from 1 to 2 of 1 over x squared dx? That's going to be negative 1 over, this number appears here as the minus, the bottom number appears here as the plus. So this number appears here as the minus, and the bottom number appears as the plus. And then 2 to 3 would be 1 over x squared dx. You get negative 1 over 3 plus 1/2, and so on, right? Okay, so once you are convinced with this, then what you can say is integral from 1 through infinity of 1 over x squared dx, according to that picture there, that's like integral from 1 to 2, then integral from 2 to 3. I'm not writing, but you know what should be in here. I'm just skipping some things. And goes forever. And we actually know the values of these. This one is negative 1/2 plus 1 plus, the next one is negative 1/3 plus negative 1, positive 1/2 plus negative 1/4 plus positive 1/3. Okay, well, what will be the next term?
Negative 1 over 5
plus 1 over 4, and it goes forever, right? Now, do you see that these cancel like that, right? And this one cancel like that. This one cancel like that. Cancels. And they shrink. So after all these numbers cancel, I'm very, not being very rigorous here, but just intuitively, what happens after you cancel everything?
All you have is that one.
You just set 1, right? So it does make sense. So that's one way to think about it, but then you might also question like, oh, how can you add infinitely many things and still get a finite number? To explain to you how that can be possible, well, some of you learned this as geometric series, but suppose you have 1 plus 1/2 plus 1/4 plus 1/8. This one has nothing to do with this calculation. I'm just trying to make a point that you can add infinitely many things and still end up with a finite number. Okay, does anyone know what this value would be if you keep doing this?
2.
Oh, did you know?
I don't know, it's just intuitively.
Intuitively, okay. Well, here's the picture. Let's say 0, 1, and 2. So adding a 1 means this is 1, right? 1/2 is half of this length. So this will be so this much will be 1. This must be 1/2, right? And then 1/4 or 4th will be 1/4 will be half of this length. So it's right here. It's 1/4. Half of this will be 1/8. So what do you see? Like every time you're adding something, you're just adding half of the distance between 2 and itself. So if you keep adding, you're only getting closer and closer to 2. So take the limit, you end up with this value being 2. So it is possible to have infinitely many things added together to get a finite value, and this is an example of such. Okay, and that's why, though it seems really counterintuitive that one side could be infinite length and still be finite area, it does work. And another reason why that does happen is like, think about 1/x². That's decreasing really, really fast, right? So that at some point, the area that you're adding is just very minimal, very small as you go right, because it's growing. If you plug in 1,000, that's 1/1,000,000. That's like practically 0. So it just decays to 0 so fast that the later ones that you're adding is like not doing much. That's like another way to think of it.